So as we continue with lesson 3.2, now it's our time to how to properly identify whether a function is linear or nonlinear based on how it looks in a table. So the first thing you're going to make sure is what happens with the x values. So look at this. We look at the x values, and as you can see, we are consistently increasing by 3. So once you make sure of that, the key point here is going to be taking a look and concluding what happens with the output. As long as there is consistency here, okay, checked. Now you are going to look at the outputs. Now, look, what happens here? From 36 to 30, just went down by 6, or you subtracted 6. What happens from 30 to 24? Subtracted 6 as well. What happens from 24 to 18? Well, you subtracted 6 as well. So, what's the case here? Well, in this case, you can conclude as x increases. How does that increase? By 3, right? As x increases by 3, y decreases. How does that decrease? Decreases by 6. In this case, you can conclude this. Sorry, let me use another color. Look at this. I want you to start identifying this. Can you see there is a connection here between how the x change and how the y change? There's always, in this case, a connection of negative 6 plus 3, negative 6 plus 3, negative 6 plus 3. In this case, we say that the rate of change is constant. Okay? This is an important concept that we're going to get back to it soon. Since the rate of change is constant, that's our conclusion after I did the negative 6 and the 3, negative 6 and 3, negative 6 and 3. That's the rate of change is constant. Hence, we have a linear function. Okay? Now let's take a look at another example. Again, let's begin with the inputs. What happens here? Plus 2. 3 to 5 is, again, plus 2. 5 to 7 is plus 2. Good? Now let's focus on the output. This is the key here. Okay? Let's see what happens. From 2 to 9, you go plus 7. Okay? From 9 to 20, you increase 11. And from 20 to 35, you go 15. Focus on these numbers. Can you see they're all different? Let's get back to our previous exercise. Can you see that we had negative 6 every single time? That is what makes the difference. Here, as x increases by 2, okay, y increases as well, but not by a constant amount. It increases by different amounts. And that is what makes it, or makes us conclude that the rate of change, and sorry for my writing, guys, beforehand, because I know it's terrible. The rate of change is not constant. And when that happens, you say, and you conclude, so the function is not linear. All right? So what determines in a table when a function is linear or not? The rate of change. What is the rate of change? You compare how the x and the y vary. Okay? When it's constant every time, as you can see here, you say it's a linear function. When it's not constant, as you can see, then it is not linear. All right?